So it's clear from the cognitive models of computer vision, or sorry, of the cognitive models of vision, not computers, that we appear to use features of objects in order to identify them. Those features, if you think of Ma, can be hierarchically organized. They can be color or grey level. Texture, I suppose, encompasses pretty much everything, but texture implies a repeating pattern. Edges, corners are things that are discriminatory in terms of computer, perceptual things, and we can look at these two board rubbers as an example of that. You can see there's a different footprint. They present a different shadow to a computer if there's a camera taking a picture, and we can look at the front side and observe that they have different markings on their surfaces. So if we can develop a system that can register markings in some structured way, or just profile, shape of profile, then we stand a chance of being able to recognize objects. I want to talk about two different types of ways of looking at things in computers. One is using contours, which are enclosed edge boundaries of things, so the perimeter, and the other is regions, which are islands of some shape. So you can see that both of those are islands on a whiteboard. So you can imagine, in a computer sense, because now we're looking at trying to do these things, recognition by computer, that we can somehow isolate these based upon their grey level. If we assume they're both monochrome pictures, and that the white is has a grey level of 255, which is convenient for 8-bit encoding, and the other parts have grey levels that are equal to or lower than 255. So the contours will be the closed, will be the boundary, and only the boundary, or the edges inside. So just look at contrast on those. Whereas the region will be as if you have, if these are islands in a sea, and you conceptually add water to the picture, flooding all of the background, and then you end up with a region which is an island, so it has area in terms of pixels, and you can then compare the area of this with the area of that, for example, and be able to discriminate very easily just on area, let alone any other shape. So there's two ways of looking at objects. The task is to separate a figure, those board rubbers, from the background. Now, on this board, it's really trivial because there's a uniform background, no features, no easily discernible features on the background. If, however, I put these board rubbers here, then there's a bit more confounding information. If I present them to you like that, on my black jumper, it's even harder to see, so it's more confounding. If these board rubbers are in a classroom, then it's pretty obvious that they're probably going to be board rubbers. If you see them lying on the grass or in a car park outside, you're not sure what they are unless you closely inspect them. So there's a question of complexity and a question of scale in computer vision, and you must fixate this in your heads. That if the scene is very simple, so the items are known, like these board rubbers, which is classic of an industrial inspection task, when you know exactly what you're going to be looking for because you're trying to manufacture it. You've got the CAD models for it, so you know its detail in infinite precision. And all you have to do is to present that item in front of the camera at a predetermined time, and then take the picture, and you know that that should fit your CAD model. And then you are looking for discrepancies between CAD model and object. So this is a simple scene. The parameters are extremely well defined. It's a known universe. There's probably, let's imagine on a production line, you might have 10 or 20 variations of a board rubber that you might want to you might want to check to make sure it's being assembled correctly, for example. In a simple scene, we want to control the lighting. So the grey levels in the picture will be very repeatable because the light source will be fixed, it won't change, it will be of a steady illumination. It could well be of a diffuse type, so there's no highlights on the objects. And then all you have to do is to make a threshold between the brightness of the background and the brightness of the objects, and that threshold performs the figure ground separation. It makes everything that's darker than the background, if you have a white background, to become figure, and everything that's white or near white is going to be the background. Is going to be the background. And you can then use simple shape analysis tools like morphological shape, which are available inside toolkits like OpenCV, and they will give you a simple set of numbers that represent that shape to some level of complexity. If you match that set of numbers for an unknown part, then you can have some reasonable degree of confidence that you have found the part that you are looking for, because there's only a limited set of these, and you've got the sets of numbers for each of those parts, and there's clear separation statistically between those sets of numbers. This makes it very fast, so you can do industrial inspection at 10, 20, 30 frames a second if you have a carefully tailored system, and you can be inspecting anything from the assembly process of an iPhone through to assembling Cornish pasties on a production line and making sure that they've all got the right features on them. But there's a spectrum, and the spectrum starts at this simplest end, and at the most complicated end, the complex scene has an unknown number of items. You don't know what's out there. You may not have seen some of the things in the scene ever before. Now, it's very hard to deal with this because the parameters for recognition that you would use to identify each object won't be known. So you have to make your machine, your computer, extract parameters automatically and then use those in some way to build its own internal representation of objects, and then use those to decide how many categories there are and therefore how many objects they're going to be. Here, in the limit, it appears that Shimon-Edelman's technique using image patches is a good solution, and here we are analysing all of the patches in the visual field, probably doing some texture analysis and looking for different textures, and then trying through Bayesian statistical methods and a slow learning process, trying to work out which textures co-occur with what objects. So if you think of bicycle wheels could broadly be split into two textures, the chrome rim and then the black tyre, just for simplicity. So if your image was full of green grass and bicycle wheels, then you should be able to, using image patch analysis, generate automatically the statistics for co-occurring frequencies of chrome and black and green for grass, for example. The problem is that this is an unbounded issue, an unbounded problem. So we don't know whether we've solved it, we don't know whether it's complete, we don't know whether we will be able to identify everything in the next scene picture that we take. We're very good at doing this. In fact, we're so good at doing this that we don't even notice how complicated it is until we try and do it by machine. So please bear this in mind, that when you're looking at a computer vision problem, that you consider where in this spectrum it might be. So for example, simple scenes are going to be presented as two-dimensional images with features to be compared. Complex scenes are likely to be three-dimensional scenes. Simple scenes will have structured lighting, very carefully controlled lighting, doesn't change. Complex scenes will possibly be outdoors or on different planets if you're making a Mars rover, for example. Simple scene, you've got models of all of the parts that you want to identify. Complex scene, you have no idea what you're going to be looking for. You might have a few of them built in, but then you've got to react to new ones. And that's the task of an autonomously guided vehicle. If it's trying to avoid things, you want to be able to write your software so that it can identify anything that's moving and try and decide what category it's in. Is it dangerous? Is it to be avoided? Do I need to track it? And so on. And there lies the complexity in the machine vision analysis. So we're going to look at some simple things for now, and we're going to look at some simple techniques that are going to be good for industrial vision inspection, but you can use them to build complexity. So here's a really simple situation. We've got two test examples, one with 2 coins on, one with 2 coins and a pencil. A third one with a board pen and another coloured board pen. These should be online on the DLE. Later on we'll have a look at trying to explore how to threshold those, but let's walk through an example which is a code called threshold.cpp. So we're going to do region detection first, and the first thing to do is to establish a grey level histogram. So this histogram gives us the number of pixels in this picture that are bright or dark. Notice now I've inverted the signal so that the background is dark and the foreground is light. Okay, that's just for convenience of explaining, but you can, of course, if this on the original one, oh, actually, sorry, that's completely really wrong. I don't know why I did that. So on these ones, we've got lots of white and some black. I've inverted them here, which doesn't help the analysis, which is what I meant to say, but the white pixels are the background and the dark pixels are the foreground. If we apply some threshold in the middle here, and here you may be able to see it starts at 0 and there's no pixels that are absolutely 0. They're all some level of grey, going up to mid-grey, which is 128, going up to 255, which is pure white, but actually we get up to about 248 on the pixel value. So the background is not pure white. We apply some threshold in between, and then all of the pixels that are white we assign to be black, and all of the pixels that are grey, bit less than say 100, are assigned to be object, and they are mapped as white. So that's the pen and coins. Let's now look at the board pen and the marker pen. Here we've got a much tighter distribution. There's a lot more white in the picture and hardly any grey. It starts at 100, so it's mid-grey. But this is a colour picture, and I've had to convert this colour picture into a monochrome picture in order to do this example. Notice most of this board pen here is white, so it's very hard for the computer to see this edge here and this edge here. This edge here, however, has a nice shadow on it, and so this comes out very nicely, but this doesn't here, and is merged into the background, as you can see from my threshold here, where most of the pen itself is linked erroneously into the background. Now the problem is that we're making such a simple assumption that all of the object is going to be a different illumination to the background. That's what we're relying on. And for pencils and coins that is true, but for board pen that's not true. So we have to be very careful about how we analyse, how we separate figure from ground. That's regions. This is now using contours, and for contours we use edge detection. So we detect a contrast edge, and a contrast edge is a strong contrast edge is a step change between light and dark. So here's a step change between light and dark on this side. On this side we can see shadow, so this is not going to be such a strong contrast edge as on the illuminated side. So for the pens and the coins, we look at the coins and we can now see surface detail on the coins. So this is simply because when we illuminate this from the surface, we get all of this low contrast information, and we also get the boundary of the object. But actually, if we adjust the threshold, and here you can see there's a little slider scale which is adjusting the threshold to decide how strong an edge we are going to accept, then if we accept all edges as being valuable, then we get a strong background. If, however, we reject all of the weak edges and we only look for strong edges, then we start to see that this part of the background disappears, and we start to get now some of the texture on the background itself. With care, we can set a threshold that allows us to separate out all of the perimeters of the objects. If we try and do the same for the colour pens, and here I again converted them into grey level, you can see both pens are very difficult to perceive using this contour technique. We get large gaps due to the reflections, and you can see on this one that, actually I'm sorry, I've been doing something slightly incorrect here. The threshold on this is strong thresholds, and this is so strong edges, and this is weak edges. So this is giving us lots of weak edges, which effectively is some specular nature of the illumination. So a moderately strong threshold gives us moderately strong edges, so we've lost all of the contour information inside the coins, but we have still sufficient to detect the perimeters. If we look for very weak edges, we can see that the illumination, which was from a point source in front of the scene, you can see that there's a boundary of intensity that I can detect by reducing the sensitivity to pick up all of the edges of the specular reflection of the paper that these were placed on. The problem with this type of analysis, although it's simple, and once it's set up and with appropriate light source it is reliable, is that you have to set the threshold manually for every set of objects that you are going to be testing. You manually have to establish all of these. Now, for industrial vision, that's not a problem, because you're going to have an enclosed light source, it will be constant, you're going to have the scene is going to be set up, and all you're going to be doing is changing the things that are presented to the camera. So once you've set the threshold, it will work reasonably well. So what do we do with contours? Well, this is obtained through something called edge detection. And the simplest, or one of the simplest, is Sobel's filter. And here are two parts of that filter. One is in the X direction and one is in the Y direction. You can see that they've got positive ones here, positive ones here, negative ones here, positive ones here, negative ones here. These are differentiating filters. The way this works is that you place this filter over a picture, and let's imagine that this white part is the whole picture. So this gets moved up here, and you then multiply every pixel by its equivalent matrix element here. So the first pixel is multiplied by -1, the second by 0, the third by +1, and then we go down, and on the second row, -2, 0, 2, and then down -1, 0, +1, and we add the results all together and sum them to produce a result which goes in the middle of an output image. So you have an input image and you have an output image. By processing all of the pictures, so you repeat that, you move this filter along by 1 pixel and repeat, along by 1 pixel and repeat, and along and along and along, and repeat for every pixel in the picture, doing all these multiplications and additions together. And you do that for the X direction, you do that for the Y direction, and that then allows you to combine those two differentiated images in the X and in the Y direction, so you can get the magnitude of a contrast edge through the sum of squares, and you can get the phase angle, so the light orientation angle, the gradient, from the arctangent of the ratio. So using Sobel's filter, we can process a picture and generate two output maps. One is the magnitude and one is the phase. Here is what they look like.
Excuse me.
Yes.
That matrix, when you multiply in X direction,
yes,
you go that way, where you go every pixel down.
Yeah.
And in the Y direction, you just do the same thing on the same pixels.
Yes.
Down. Oh.
Yes. So you end up with, you have two intermediate differentiated pictures, an X and a Y, and then you combine both of those to give you a magnitude and a phase, which will give you the magnitude and the phase in any direction rather than just in the X or the Y direction. So here here is the magnitude, you can see, and this is the phase information. Here is magnitude, I'm not sure why I've got two of those. Here's magnitude and here is phase. Now, the phase information, because we've got a light source that is in front of the object, the phase information is going to vary from being 0 here, round to plus 128, round to plus 255, because these values are all normalized to a byte for convenience. So you can see that they, if there's an edge that is vertical that way, bright and dark, then we end up with 0. If we go around that way, there's an edge there, which is, if you think the coin is dark against white, then that's mid-grey, and then we start going round here, and we end up with the orientation. So if you imagine there's a little vector arrow on there, it's kind of doing that. And you can cluster these with the appropriate software. You can cluster those, noticing that there's a smooth variation in vector arrow orientation, which will tell you that there is a continuous edge all the way around that object. People don't do that though, because it's slow to do. Generally, they select a magnitude of the strength of the edge. So here's a good example where we get a strong white edge there. So we take the differentiated picture, and we then apply a binary threshold to that. So we accept everything that's strong white, and everything that's grey or black we just reject. And that leaves us with some very simple descriptions of the perimeters of the objects. You can add complexity to this by using the Canny filter, and a chap called John Canny in 1986 published his PhD where he studied step edges. And here you can see this is a step edge in noise taken from one line of pixels going across a picture. So here the pixels are generally below some notional average, and then suddenly they change to be notionally above that point. If we use a box detector, and this is in profile what the Sobel edge detector looks like. It's just through one center. If we look through the center of the Sobel, we look through here, -2, 0, +2. This is the filter, -2, 0, +2. Okay. In fact, this is an even simpler one. This is just -2, +2. There's no naught in the middle. And if you apply that filter to that, and the technical term, the mathematics, is called convolution. So you convolve the filter with the image, then you get this. And this is what happens when this starts here, and you do what I said with the Sobel filter: multiply and add them all together, move by 1, do the same, move by 1, do the same, do the same, and for every output you plot the result here in this x direction. This is the result of convolving that box filter with that signal. The problem is that with noise you're not actually sure precisely where the edge is. There's several peaks there that actually could be the center of the edge. And what you're doing is you're trying to find the center of the gradient of that step change. So he suggests that we use a first difference of a Gaussian, and this is the first difference of a Gaussian. And we use this as the edge detector rather than this box detector. The advantage of using a first difference of a Gaussian is that mathematically this is producing a filtering function. So this is a low pass filter as well as a differentiator. It's a differentiator simply because we've got a negative part and a positive part that are adjacent to each other spatially. And if we then apply that, so we convolve that with the noise, this is the result. You can see it's a low pass filter. It's slowly varying. There's none of this high frequency you might call noise on it, and there is just one peak. So Canny suggested that this is a good technique. So this is actually preferred. So the Canny filter is very common in industrial vision applications because it suppresses noise and makes it easier to determine the location of the edge. He also went on to say that you can have special detectors, and here is an edge detector. Well, sorry, this is a bar, a bright bar on a dark background, and this is the matched detector that you should use to preferentially see that. If you want to identify a ridge detector, so look at a roof, for example, then that is the detector you should use for that. So in any computer vision application, you could generate a matched filter. So this is a matched filter for that, this is a matched filter for that. This will find this in the presence of noise optimally. This will find this in the presence of noise optimally, and will generate that location as being the center of that box, of that ramp, and here would tell you where the centre of that is for that particular stimulus. Canny went on to look at ideal detectors for step edges and found the first order of the Gaussian to be within 10% of the theoretically ideal step edge detector, which is very difficult to construct analytically. So everybody uses the first order of a Gaussian, and what you're doing is you're just choosing the width of the Gaussian to determine its characteristics as a low-pass filter. So we filter and edge detect. Oh, it's within 20% of the theoretical optimum. We then do non-maximal suppression. So for every edge point, we look around and only accept the strongest. And then we join edge points with hysteresis. So this means that we accept some threshold of contrast, and if we go above that, then and then dip down, provided we don't go below another threshold, we still regard that as joined to the same edge points that we were looking at. And we do this at different spatial scales, and we do that at different spatial scales by choosing different Gaussian standard deviation widths. So Canny is available inside OpenCV, so we can have a look at Canny as well. So you can see I'm building up some things to try out so that you can explore their properties using an OpenCV program. Once we have a region, or we have a set of contours, and in order for shapes to be recognized from contours, those contours need to be closed. So if we look back here, you can probably get a closed contour from that by setting the threshold such that the greyest value on this edge is the least one you accept, and then all the brighter ones will join it up together. Here you can see there's a gap, and because there's a gap, the openness of the contour will stop many algorithms that recognize shape from actually working properly. So you have to use closed contours. Let's do some simple measures. We can look at the length and width of an object, or the area or the length of a contour to discriminate. So we could look at coins, for example. We could be looking and measuring the length and the width of the pen or the coin or the object, and you can see that we've got 5 objects that are roughly 100 in length and varying between 50 and 72 in width, and we've got another set of objects that are less than 100 in length, varying from 50 to 72, and they're more symmetric because their widths are more 50 to 72. So this could be pens versus coins. If we plot those on 2 dimensions, we can see 2-dimensional clustering here, but notice we are putting the clustering on here. I'm suggesting there could be a line that goes across here that allows us to discriminate between coins and pens, and we would then be able to label those accordingly. So we've done some detection by doing a clustering on 2 axes of dimension, and we can add more axes. We can make that 3 dimensions, 4 dimensions, 5 dimensions. Whatever properties we are measuring, we just add another dimension to the discrimination function. If we can project to 2 dimensions from our multidimensional measurements of parameter, we can then best fit an ellipse to our objects. And here is the maths for doing the best fitting of ellipse. It generates the major axis, the minor axis, the area, and the orientation or eccentricity. And this is also available inside OpenCV. It becomes part of analysis by moments, and these are geometric moments or morphological moments. And again, this is something else that you will need to be looking up inside OpenCV. So if we just recap for a moment, each one of these slides is prompting you to have a look on the OpenCV documentation to see what it says about those and to try out each of those functions. There are plenty of examples that abound that show you how they work, but you can also build your own. So, moments. Moments work with contrast edges, which have been joined together to make contours. So here we're going to make a linked list of contours that describe the objects. We will have applied some threshold so that we reject all of the weaker lines and we only have single examples. But we're also going to select the option to close the contour. So whenever we get a contour, it will then try and jump across all of the contours that are nearest to the other ones and produce some closed contour that on the outside, that encompasses everything that we can then use for shape analysis. Now, moments came about through the need to recognize shapes before computers were actually as sophisticated as they are now. So a chap called Hugh in 1962 developed a way of recognizing shapes that relied upon you going through the image, and here's the image X, here's the image Y, and this is the value of the X and Y location. So maybe it's grey level, maybe it's colour, and summing those across all of the pixels to produce a moment. So if we set P and Q to be 0 or 1 or 2, for example, so the moment for 0, 0, where P is a 0 and Q is a 0, that means that we're going to go through the whole picture and we're going to add up all of the grey levels for that picture. If the picture is grey level, then we effectively add up the total intensity of that object. If the picture has been binarized to make it into black and white, then we're counting the number of pixels. So M00 for a binary object is the area of the object. M10, where P is a 1, is giving us the values at in the x-axis, and 0,1 is giving us the values in the y-axis, so that we can evaluate the length of the boundaries or the length of the region object, and these are giving us the precursors to fitting of an ellipse. So the location of an object is the sum of all its x and y coordinates. So this is the sum of x coordinates divided by the number of pixels. This is the sum of all the y coordinates divided by all the number of pixels. And that then gives us the center of mass of the object, the x position and the y position. So for these two objects, that would be probably around there and probably be around there. The problem with this centroid is that if you move the object, the centroid moves. But that's actually quite handy, because that's then telling you where the centre of the object is, so then you know where on the screen the object is sitting in the image. But if we want to calculate the orientation of the object, then this is going to change according to the location on the screen, and so we have to subtract from our higher moments. So if we're looking at moments that are describing the distribution of intensities across the object, then we want to take away the centre of mass from the calculations, so the position on the screen is immaterial. It's invariant to translation, in other words. We can then also do that for rotation, so we can remove the parameters that give us rotation. So we then have some numbers that describe the object regardless of where it is in the picture, and also regardless of its orientation in the picture. And the last one is its scale. So it doesn't matter how big or how small it is, we will still recognize it if it occurs in the picture. So we get all of these moments, and I'm not suggesting that you attempt to understand the central moments, but if you combine these in a way that is invariant to translation, scale and rotation, and here is the naming convention for that. So this is the squared x value, the sum of x squared and the sum of y squared is the invariant matrix I1, and so on. You can go through here to get I1 to I7, which are Hughes moments. And Hughes moments are available inside OpenCV very conveniently to be able to recognize objects. It's a 7-element vector, a 7-element matrix for any binary shape that you have. And you can then compare binary shapes and assess whether those 7 numbers can discriminate between your binary shapes. That is one way of describing an object and recognizing an object based upon its shape that is invariant to translation, so where it is in the picture, scale, how far away it is in the picture, and rotation, its position in the picture. Now here, remember, we are only looking at 2-dimensional rotations. We're not looking at 3-dimensional rotations. That adds an additional major complexity that will confound most of these simple systems like moments. So try out Hughes moments on the examples, and maybe try them out on other pictures that you have. There's plenty of examples that are bound on the internet. Okay, so I'm not going to cover any more today, but what I want to do is to show you on the code repository. We've got Sobel and contours 2.cpp, which are particularly relevant for us today. If you look on your C drive and you look in repository, sources, samples, there's something called contours 2. And oops, that's no good, is it? I'm not sure what this is going to open in. This went crazy like Visual Studio, which will take forever to load. This doesn't require a camera. It gets you involved in what contours are and allows you to understand. That's really useless. Oh no, it's here. So here is the code for contours, and this is all organised around the concept of a repository which you can add to on your particular machine. So for example, in projects you'll see that there's an OpenCV samples project. If you double click on the .pro, this will open up the Qt window, and we can then open up the samples. We can see the contours code in here. We can combine it with a rebuild. We check down on the right bottom to see if we get a green light, and if we do, we can click on the debug button, which is this green arrow with the debug on it on the bottom left. And now we can run through this code. We could single step through it, but I'm not doing that. I'm just running the code as is, and you can see I've got a test picture on the left and a set of contours and a slider button that I can use to define what processing I'm going to do. So this is a convenient way of getting mouse input from the user to change the processing that goes on inside your program. So contours.2 is exploring two things: contours and screen output and screen input, so that you can get input from the mouse. So I'd like you to open up Qt and to run through this. Let me just go through that again. So the easiest way of getting there is to go to Qt Creator Community Edition, open that up, and you will see Contours demo, OpenCV2 examples, and in there's only one piece of source code, and it's the one that we were just looking at. So I'd like you to all open up that, go into build, do rebuild, project OpenCV samples, let it run, pull the two screens apart, and play and go through the code, look at contours on the OpenCV website. Yes?
The build button is greyed out.
No.
Yeah, I have the same issue.
Oh no!
Contours 2, what do you want to...
Oh, wait a minute. Yeah, that's because you just opened
Build it.
the...
Can you build it?
you just opened the C
Oh,
code.
you did it.
Yeah, no, you've got to open the project. So you have to open the project as I did there, otherwise you just open the C code and it doesn't then bring all of the other compiler rated stuff in. Yep. So now you should be able to, yep. You've got the same problem. Yeah. Okay, so down there, Qt Creator Community, it's same for you. You've got it, and then click on, go here. Click on that project, that's it. And then click on sources, and then click on the contours2.cpp, and then go to the menu and click on build, rebuild, halfway down. No, just the single one, you don't need to rebuild everything, just that one. Move it up the screen a bit so you can see the buttons at the bottom, and then click on the debug go button, which is at the bottom bar one, the green, no, one down from that. So, yep. And that will then run, and then you can tease apart the two windows that have been generated and overlaid. Have you got those? Are you using Visual? Did you want to use Visual Studio? Yeah. Okay. Well,
I'll try to first.
all right. Okay. Yeah. So close that. Okay. Did you click on that? And then go to C. Oh shit! This is one of those. Let me get my glasses. Hold on. Now. This code, if I can interrupt you for a moment, this code all exists on the C drive in OpenCV31 sources samples CPP. So OpenCV, sorry, this is crap, isn't it? Yeah. OpenCV sources samples CPP. So OpenCV31 sources samples. Let's just magnify that. OpenCV sources samples CPP. You'll see there's a whole bunch in there. So those are the samples that come with the OpenCV library that are specifically for C++. If you go back one level, you can see the samples for things for Android compilation or for Python, which might be suited for some of you instead of using C++. So if you do this on your laptop, you should be able to download the CPP, but then you'll have to create your own project. So if you want to do this and you need some help, stick your hand up and I'll help you. Right, where are we? No, you won't find any. May I interrupt you? This is a cake, isn't it?
Do you need 3.1?
Yeah. Right.
Phil probably knows.
So what we're going to have to do is we have to generate a new and non-Qt projects can be and
What else is correct?
and
Eventually,
we could, do you want to put it in documents? Let's,
it's probably different way around about it, unless conscious just install this one down.
can I navigate to documents for a moment?
It must be some sort of stuff.
What I suggest you do is
I'll try
create
to
a folder in there called repo or repository or OpenCV or something, whatever you want. Okay. And then you can create a project. And then when you created a
it's one of
project,
the only versions that doesn't work.
you can then either you can then copy from that repository either into a like me, like I've organised a source projects in the sources folder. You can create a folder with sources and put that, copy that into the sources folder.
Did you ever hear anything back?
Link that in.
Her document
Oh, yeah.
on reply.
I can show you how to do that.
Well, it's better than nothing.
Next.
I prefer things to be starting.
Yeah.
Because it's real time.
And the deeper you go, the worse it can get.
That's what it is.
I know she's seen it. She made a mistake.
So I don't know if that's
That's why she made that mistake, but she didn't know.
just try both of them and see.
Maybe she's like too nervous to reply.
Possibly, we have really similar personalities. That's the idea of chocolate. She's conscious in the chat. Especially we talk about everything in the right and think about.
And now,
And yeah, she's one of the back into the lead from the personalities from the starship. So,
we're going to add stuff to that. We're going to have to do. let's just for convenience
one click.
put contours in there. I want to copy that and put it into the. That's it. And now if we this is why you might want to do it in
I see. This is solving some problems.
You're running really tired.
After this morning. After this morning.
Oh, I was tired before I even got to the first one.
Yeah.
I did go to bed at a decent time, got a decent night's sleep. I just went for a shower.
Okay, so we haven't.
Yeah, it's pretty common. I usually get tired about now. I don't feel too bad. I quite often get tired if I've been up there. You don't have to get up early tomorrow then.
Probably just going to the gym.
It just does it.
Not
It'll tell you. Number.
I need to go through but then we're not going to go
That one. That one.
different methods. I'm going to go through that. I'm just going to go
I should send you my
Where you start,
I
actually.
forgot to send you.
You know where she is?
It's the
I didn't have time to do it.
But she's not moving.
Yeah, I was asleep. So tired. So not a chance to do anything.
This isn't a computer.
Yeah.
PlayStation's just gathering dust at the moment. That's essentially I've not been on it.
Yeah.
It's been so neglected. This uni year, this academic year, it's been so neglected.
Yeah. I haven't really played much games. There's a big update for a game that I played today, but I just haven't played games for about a month now. Played some.
Probably more updates.
Well, there's one today. There's a big one. But I can't really bother playing games at the moment.
Like, probably like up to update right here.
It's not actually out quite yet. I don't know when it's going to be out today. But yeah, I'm not that bothered anyway. Because I've got so much work to do at home anyway.
Yeah, I understand.
I'm trying not to get back into the habit of playing games. So I'm an addict when I start playing games.
You don't necessarily have to play some updates take ages to install. Maybe if you're really busy tonight, just knock the computer on for a minute.
Yeah.
Set it to do the update.
Yeah, it's 10 games, I think.
Put it in standby. Done.
Yeah.
You might just do that the
Yeah. It's on Steam anyway, so it'll like download it in the background.
And then you can choose
Yeah,
whether
it's
to go through the consent.
Maybe you can set it up.
Yeah, on Steam.
But at least you know what you're looking for.
I usually let it only do it
Shall I do that?
like at night and stuff. You can set
You
want it to like,
You carry on doing it.
but it automatically.
Let me just show you how where it is all along.
So I like my computers, they can take ages to download.
Yeah.
The
Yeah, it
trouble
depends
with
on your
the-
internet connection as well, you know. It's, oh, that bloody Vodafone internet
The
thing.
trouble with QT
The bastards.
is the
I
same
told you
trouble
they didn't turn up, didn't I?
with Visual Studio.
You know,
Set up-
when your exam was, because I said that they were going to come to install it.
And
You know when you had your exam,
look at
I said that I had to stay at home to wait for them to take into it.
Yeah.
They didn't turn up. And then they said it again. And last Thursday they said that they would come to deliver my router. And they didn't come.
if you look at what's
I
on
phoned them
here,
up, and eventually, I've been trying to get this
Download
since
it.
November. Eventually they looked at the system, they said, oh, you get our internet package where you live. And so they've tried to deliver it like 3 times. They've already charged me like 62. I've tried since November just to get them to install my thing.
import
And
that.
they finally, come February, tell me that I can't even get it.
Copy it into
I'm just like, well, why
Then you
didn't you
can-
tell me that in
then
November?
you complain about it.
I wasted 10 hours. I spent 10 hours going to it.
In that case, you need to claim back that money because you've been charged something you can't get.
Yeah, well, I think they'll give me my money back, but now I would like
That
get
is-
some compensation for 10 hours. Literally spent 10 hours waiting. So they told me one day they gave me a 6-hour slot, and the other day they gave me a 4-hour slot.
That's where
I waited for the whole slot. And then I phoned them.
It's always right. Since they've reached the time of compensation.
They never let me talk to them after. I asked, but they never do. I think they're just
Basically, they just hope that they don't do anything and they'll just go away.
yeah.
It's basically like they're talking about backside and they mentioned it.
Yeah. And then I think on Friday or something last week, after I cancelled it all, early morning and Friday, and they started talking about installing it. I was like, look, you've already told me I can't have it, and I've already cancelled it. They were still phoning it.
Right.
They're just rubbish. They don't know what they're doing. Yeah.
So it sounds like they haven't really organised it very well.
No.
Miscommunication.
And every time you call them and you do something, like the person you speak to doesn't finish what they're doing, they just go off and have coffee or something, and they don't like complete your forms, so you end up with incomplete data, and no one knows what anyone else has done. That's what half the
It's just
problem
finish
is.
what they're supposed to do.
Yeah, they even got my address wrong. Like they asked me my address and my last address. When I went on the website to have a look, they put both of them wrong. Like absolutely. Literally everything.
when you need to
Everything, apart from taking up payment details, anything like
It sounds like they're not really the company you want to use.
no, I don't want
I'm saying to different company about it. Their customer service is that bad.
Yeah, exactly. I've cancelled it all now. I was just like, I just don't know anything to do with
That
it.
may not. But if you ever have a problem like you have right now,
Yeah.
you're not going to get.
Yeah, when they said eventually, right at the end, I was going to cancel it anyway, and they said, the service is available in your area. I was just like, good, I don't want it. So at least you can't have anything to do with me then.
And remember that there's a document called QT_PFC.pdf, which takes you through the first steps of getting into QT and also how to build new projects and make them work with new bits of source code. So you need to read through that document.
So there's one thing on project, I mean the 2.5 Nash.
Yes.
That was compatible to Mac. I'm just wondering if you know if it's 3.1.
I'm using 3.3 on my Mac and it works fine.
Right, so would that make it suitable for...
Yes. Yes.
So,
So just go to
student downloads.
go to the OpenCV. You'll have to build it. You'll have to build it
so I've got...
using CMake.
You're blind?
So just go to OpenCV on the web, on the internet. Download 3.3 sources.
So I'm just taking live and trying to think of
Yep. Do 3.4 sources.
sources, huh?
Yep.
Okay.
Wait, that's in downloads.
That's downloading it now.
Great.
Once it's downloaded, unzip it. Use CMake on it as the documentation says.
It's on the visual lecture.
So CMake configure, CMake generate, and then do the make and the make install that you did last time.
I'll try and remember.
It's all in the documentation.
Okay, right. So, mostly, obviously, same documentation in
Look on not my documentation because you're doing something that is off-piste. This is the OpenCV documentation for that version.
Great, that's fine, right.
Yes.
Right, just making sure I know about everything. Okay, fine. Yeah, that's perfect.
We all would like coding and we said that we want that. All would like to.
We're free, isn't it?
Currently I have OpenCV 2.4. We've also got iOS Pack. So
okay.
this is the sources I'm showing iOS.
That one's great. Oh, yeah. Also we use lower level.
I'm just going to punch on the desktop so I can actually see it.
Is that what your bedroom looks like?
Sorry?
Is that what your bedroom looks like?
So it's like
Is that what your bedroom looks like? Stuff everywhere.
no, I keep it with
Oh,
it.
yeah.
This thing is actually quite tiny. It's like I've got
If
it.
you know, oh right.
Go on. The whole junior part.
See,
You
go for coffee.
I was trying. I was theorising that maybe people who've got like really messy desktops or like messy bedrooms.
Mine's been quite ordered.
Oh, is it? That's odd for a student. He's the odd for a student.
Yeah, I just do this is ordered for me. I know that.
Yes,
ordered.
yeah, exactly. That has to be right. You
Okay, so this has got one of the CMake, everything like that. I just need to find out.
So this is all just
install. I've got iOS Pack.
There was nothing.
It says it start to download shortly.
I thought it downloaded that.
So
I thought it did.
that's the thing. That's the source. This is the iOS Pack.
Oh right.
Now I'm trying to find a bit documentation that tells me how you do it.
Because you asked me to follow the thing in the laptop. Yeah, no. I know. You
But this isn't telling me about this.
You know what? I was watching that video for only my video.
I've got 3.4 iPhone computer.
That's why I use Python. You see that feature of that?
Yeah,
Wait for me.
that's really like.
You don't have
I'm talking some trying to work out. On here, I still have part 2.4, I think, because we went through the process of doing CMake, Xcode and all that. I think with stuff in here, happens soon. CMake sound thing. Yeah, that's what we're doing now. So what you were saying was open CMake configure, CMake generate, and then configure like that. That's a documentation one. And the problem is the documentation that I mentioned. This talks about when you use it. So what's the module? I presume I can use the iOS pack. Because we've got Windows, iOS and Android. And the problem is every time I click on this, go straight to send and install.
Yeah, usually you can just wait or go on that problem.
It's fine, right? What is it? Class is CV2 to 3. That doesn't make sense. So it's open CV2 to 3. Is that right?
Presumably.
Oh, okay.
Also, there's a link on the internet if you search for all the OpenCV documentation, and this includes tutorial information at docs.opencv.org/master. You're making some progress here. Well, once you've got it set up, it will be straightforward to do that. The thing is, you have to copy the same set of properties between each project, and the properties are where the libraries are, where the include files are, where stuff like that.
You've got 3.1.
That's it.
That's 2.4.
That's
It's just that to download.
Now, OpenCV World 3.3 for all of the OpenCV 3.3.
I think 3.3 was down that
procedures, so
that might be the one.
so that really simplifies
If 3.4 will work.
just getting library.
It's just that to download.
That's good. So
Really?
you're clearly a master of Visual Studio, and it's going to be better for you.
It's not that much, it's not really much, I think. This one is for the settings to download, so. And the problem is, didn't you say that the typing aspect on,
Yeah, in the documentation. Maybe you download the documentation with it.
this is the documentation.
Okay.
It doesn't mention how you do it.
Would it just be in the tutorials? Surely it starts with installation tutorial.
Ah, here we are. That's the one. Installation,
Oh yeah.
no, not that one. Installation. I've got CMake. Yeah. installation on iOS and Catherine.
Yes.
On iOS,
Oh yeah.
that one says, so does that mean anything higher than 2.4.2?
Yeah.
That says
Yeah.
I mean,
It is Boolean, isn't it? Yeah. Greater
that's
than. Greater than.
yeah, I've got
The one I needed.
well, I've got
Me?
that's the source. You can see making command on that. So when it means that's going to you can see the download it. So I've got it on my desktop now. So you want see me
This documentation.
where's the source code? Not browse source, so when I go to desktop and look for it, isn't it? CV, that's it, that's the only one. Nice about the binding. Now that was static binding.
How do you have to do it?
Yeah, this is sleep.
We have a number of robots, like four, perhaps.
This one mentioned.
So,
What's
number of
So I'm
robots.
taking the time.
the
Open city building.
yeah. What do we have to do? What do we have to do? What's the assessment for?
Do you have to do the bit above it first?
And
That's about the gap.
Yeah, okay.
That's cloning the
so you
frequency.
just do the square things here.
This is the way I did it before. But the old fix said built, but I don't know.
Alright. Yeah, we can do the basic picture.
Let's build the final. Well, it's static.
It's not, yeah.
This is not enough information.
Many things, that's it. We've done square detection, we've done failure detection, we've done safety detection, distance calculation.
That's it. Not like open CV2 base.
Hanging years if you're using it for the first time.
I find everything's about implementation gap.
Is there?
Failure.
All documentations as well.
Yeah, we've done that for you last year. Yeah, last year we worked on that. Last year we even got code for that.
There is a further reading.
It's because the outlook is not me, so
Yeah, I'm just going to say.
you ask why the outlook is slow, because it's basically slow. It's like the same why and Lisa, 100 HP is going 100 HP because it's made for That's what I was asking. Yeah, about everything. I mentioned that even if everything now is private. So everything now is private. There are no more guys like a Chinese guy to get in there. Get the whole thing there. I'm just saying, guys, like, not him. Yeah. So you don't want anything like that. You just get in there and everything. Maybe mess with everything. And even before me, and then say, oh, that's my boy. You know what I mean? I'm working obviously with setting up stuff and friends, but you'll have the stuff.
That's the thing.
I would like someone who's at least will do nothing to come and say, it's like last year.
No. All we're doing now, next on Thursday, I'll go through another slide and we'll keep going through software. There'll be a point where we have a.
Is that just in
owls?
Yes.
You see, you've got to push hard on these.
I'm not sure which one is supposed to be Oh, right.
I think the camera punch it. I think
Oh, is that the super bottle?
yeah,
I think I saw it.
I don't know what's super.
Yeah, nor do I.
I understood, so I explained from the top.
Okay, so
I mean,
Is your
I don't think this is the right sort of thing.
both.
Oh, that's easier.
No, this is
If I'm
right.
using Python, so they can configure everything which has to do with their update height, and then we're using going out and go with update height, so and that's pay for then you can do the work.
This was 2 years ago. I was thinking, so that was
High raspberry, and that will show
might have just given me.
all
If I click on here,
boards.
that takes me to one.
Oh, right.
Good boards.
Well, just assume the link isn't there, you know.
Sorry.
Just don't bother with the links. Just follow them. You can follow the guide that you can download where it says from.
No.
That's one.
Okay, as I suggested a moment ago to one of your colleagues, you need to get into this code and practice it and become familiar with how to read OpenCV. There's a presumption that you have some basic programming skills. They have to become reasonably strong quickly because we don't have much time. On each of these desktops here, there, in the samples in CPP, there is a folder called tutorial code, and that's the software that goes with the tutorials that are on this master under tutorials. So you'll see there's a tutorial for image processing, there's a tutorial for understanding matrices, and you can just quickly go through each of those. Once the skill you need to understand at the moment is how to create a new project, put some code into that project, and run with it. The simplest way of doing that is to create a new project, and the main.cpp that gets created automatically becomes the one that you paste the CPP code in here. So you open this up in some editor, you copy it and paste it into the main, and then that main becomes the code that you are demonstrating. Look in Qt_PFC to understand how to create new projects. If you get stuck, email me, but I think as a group you've probably got enough skills to be able to support each other through that process. Okay? And whilst I'm here, stick your hand up and hassle me.
Oh, hustle you.
Good. That's the right approach.
I'm just stuck on the project on the overview. It says that we can have a number of robots
Yeah.
you might like to use in a project.
Yeah.
Does that include the now robots?
No.
Or we just use
If you've got if you are working with a now robot on your main project, then a now robot is sensible for you to play with here.
Right, I'm doing the image classification in feature spaces.
Using the now?
No.
In that case, I'd forget using the now, because the now robots, unless you've got a really modern now robot, like one released late 2017, the processor on it is so old that it's going to be slower than these desktops. Way slower. It's crap.
I can't really use my project.
Well, that's okay. Well, we're providing you with owls, and those owls have got stereo cameras in them.
That's using it.
Yeah. No, this was specifically for people who are perhaps doing a project, maybe with Martin Stolen on soft robotics, that would be using one of his camera systems, or for Severin or Tony Balpin or whoever you were doing a project with. Now, if you're doing Python, you must be familiar. If you're going to, you must be familiar with how to develop Python code and the SDK that you need to use for Python. I can't support you with Python.
If you use that one, just go to
All right.
Because anyway, in Python you want to do anything, it's the only important thing which is in Python. The only movement, so like the steps, the assembly, anyway, you get reversed, so then you fit in the C++. So if you do something in Python, then everything is C++. In Python is only for communication. That's it.
Trying to make sure I'm correct.
Yeah. Still having trouble.
This
Like
one.
the toilet
Yeah.
it's actually just understand how to
This seems normal.
how to use an average.
But I don't know how to use
Literally, he says if you go through the example,
the term right
he's
now.
giving you,
So
never understand what example he
there's two ways to do it. As far as I can see, this one, but the one I know about is
my
taking like
experience
this.
was to do the
And you do
color,
things,
as he
see
said.
it, it's got them set.
You use the color printer, use
Yeah, I mean,
play with
once you have it, you see it, you figure it out.
to make
And this is why I was trying to much
RGB,
like show you. I
HSB,
think of it as
HSB to
most great one.
so that was pretty much what you want to do because part of the if you
Oh, okay.
I know
If I remember correctly, you
no,
have
if
to
you
make
if you want to use the output it's exactly the same thing mostly it's
You'd be hard to make if I could find the difference on the top.
yeah the only difference is the S
There was one last year, but
that's it
I haven't found one
you
this year.
have to just include the S with
Yeah.
by 5 minutes you have yeah if you can you go to the QT
Where?
QT
That's the only
Oh, we
thing.
use a
so in
switch.
Python you just say that without the S in most cases but in some other cases then you have to say some more stuff like the different okay
So I'm just trying to make sure I find the correct documentation explaining the installation like that. The only one I can able to find from you is the website.
That's right. It says Xcode. You've okay. This is in. No,
No,
you've got to look for. Give me your. Are you still connected on your?
no,
Okay.
you'll click my
That says iOS. What is iOS?
Can't remember the operating system.
It's your cell phone. What is this?
Yeah, that's what I'm trying to
macOS.
do.
This is OS X, not.
I haven't been able to see any process. Because my business is the GC's this is the tutorial.
Yeah. Carry on going.
Trying to find the correct one.
It should be there. May I?
and the only thing that he had is a CV2 yeah and he's using the CV2
Wait a minute. Okay.
so that's pretty much the differences not much it's different because maybe it's been something different but it's not exactly the same thing it's a type of one
This is May 2017, so this should be reasonable. Let me just check. Yeah, doing it through Homebrew is the quickest way of doing it. Do you have Homebrew?
I think we may have put it on here last year.
it's exactly the same thing
Do you remember trying to use Homebrew?
it's exactly the same thing
It's not like the shark
specifying
Okay.
so in the Python the Eclipse is literally giving me that but here you have to specify that
I'm not
that's how
found.
different
Where's your hard drive? Is it that?
That's a bit of a
That's the shadow.
usually.
Is that yours?
Before
The
training, you
downloads,
just put it
sorry,
on,
this part.
then you will get it
That's
before.
top and downloads, I think.
But
we can
if you
revert
have it, then can you run it this way? So these should be the one, like the thickness should be one. So can you go there and change the 8 to something fancy like 4 or whatever. You have to, just
Well, let's see how much space you've got.
Can you change the others as well? Because changing the one is not doing something.
You've only got 79 gigabytes free.
That must be the thickness.
That's a problem.
So, how much, sorry? I do still have OpenCV 2.4.
What have you got? 2413 or something like that?
Yeah,
But
I've still got packages that got it.
Well, use that instead. That will be good enough.
first,
Alright,
before I
then.
say why you like.
I suppose I'm thinking because of how it works.
Oh.
Well, yeah, there will be some problems with stereo vision for sure.
So I have 2.4 on my Windows computer. I thought, this is talking about using 3.1. It wasn't going to be compatible.
Yeah. You've got a bunch of stuff that's taking up. That's taking up 4 gigs. I guess you need that, do you? You
Should
need
be
that
off
to hand that the
the,
DVD here.
Obviously,
Windows 10 DVD.
so
I have absolutely no idea what
that's
that is.
it.
Well, that's going to be
I'm pretty sure the
that's going to be Windows 10 if you want to do dual boot. I guess. I don't know how you got that there, but that's taking up 4 gigs.
I remember that. That's because I was trying to reboot my desktop computer, so I might actually send that.
All right, that's OpenCV for 2413. I really think you need 3.3.
So that one doesn't work with the camera in there.
Yeah, I would. I would try and clear your machine up a little bit. So
Okay.
get rid of stuff that you don't need, like that DVD disk image, if you can,
Okay.
and then install Homebrew and follow the commands here. The trouble is that all of these things are really complicated, and as I know from speaking to you last year, you can very easily crash and burn. So you're better off using what's on there than on here, but then you can't take this home.
I was hoping to try and get something portable in case I can't get it in there.
Yeah. Well, this is the way I got OpenCV running on my machine.
Okay, in that case I'll try and clear it up. Actually, no
It did it.
Well, you've only got 79 gigs free. If you can get that so that you've got in the 80 gigabytes or more, then that would be good.
Okay, I'll do that.
So deleting that DVD ISO image will get you quite close. If you can just empty your trash can and maybe just check for any other things in your downloads folder that you don't need, or in your documents folder that are very big, and looking at things that are a gigabyte or more. Just do, for half an hour, hunt around, clear things up that you know you don't need, and then follow this.
Okay, brilliant, thank you.
Cool. Right. You can do it and clearly know what
Some of them are different.
Yeah, there are ways of doing it, I'm sure, but I never got into that, so I get frustrated with Visual Studio. But that's it, I've had a long history with Visual Studio, I'm sure it's improving.
Or on the file program. Isn't what this
Can you say something?
So if you need a camera, you can go up to Sheila in the stores on 303 and sign out a camera if you need one. Once we've gone through these preliminary things, I'll then get you to sign out the OWL robot so that you can use that here instead. But that'll probably be next week rather than this week.
Go to Google and then just type Eclipse Python command or super fast command and save you to make one of them. You just have to now and that would not move Eclipse. That's not it. And then just take Eclipse.
Oh, Eclipse is an actual.
Yeah, that's an actual.
It's a script.
Yeah.
No.
And then it's
It's the thing.
Eclipse.
Limit editor like this.
This was
Yes,
like,
no, I guess
that's
it's
why
like
that's
quick learning.
which they actually want to
So just
Alright, you don't have an external hard drive?
I quite like it.
You put it onto the disk, so you can boot it up on that. That is the backup.
Yeah, do
You can make more of this.
you put it on a USB stick or an external hard drive maybe?
Actually,
You've got one with more space.
I don't need the image format.
And then
You shouldn't need the installers.
Alright, okay.
GPUs.
Yeah, click on that.
I'm not
So now we get to the
reading
documentation.
that.
Change it. No, no, we're done.
the draws and
Like, I don't know if this one.
So that's the thing I'm telling you. So in this one, you have to include the mark point size double.
Oh, there's the thing.
Yeah. So in the Python though, you don't have to include the point. You just want to say set from and then access. You see what I mean? So that's the only difference between those two. You can literally Google everything that has to do with the documentation.
I know that much.
It's good though.
Yeah.
What's the line there?
There you go.
What?
Meant to be connected to one.
Okay.
So there's no 15, that's right. Oh, yeah, that's true. That's that. So the link should
Is that for super?
You've got to remember to clear your end. Yeah. You've got to remember to clear your recycling bin. You've got to remember to clear your recycling bin now as well. Just because otherwise it'll sit in a temporary environment.
Anyway.
Apparently I've got 81.9 subjects.
More than 80.
More than 80.
And what's this then?
Gigs. Well, all of them are all of them are
PDF. Go. Okay.
Is it that? Is it like that?
Yeah, this is
Just retarded.
let's see if I
May I
can.
interrupt you two guys?
I can always get my
How strong a
phone.
programmer
My I've got another one, hasn't it?
Okay. are you? May I just show you something? If you're going to use C, for example, I recommend looking at the tutorials for threshold. So that code takes an argument. So let's copy that. Let's go in here. Let's create a new project.
That has to do with the placements. That's placements.
Oh, shortcut.
Yeah,
In there, use that as a default application. Use that. There's the version control. And now, so I've created a new project. I'm just going to keep it really simple. So I'm just going to now paste that in there. So that is now the main here now contains that code, and we're going to take that, and oh, that's the same. It's just the include path and those. And put that in there, down there. Okay, let's save it. And let's try and see if that will work. I hope this will build. I am really okay. That's because in here I forgot to include codecs. So where's QTPFC? Where's QT.pfc.pdf? Yeah, here.
And then we'll figure out what we're doing.
So we have to have 6 Mercury video.
Yeah.
This is an old one.
It would be good, yeah.
Oh shoot.
Yeah, we can go through the code and then you will understand what the code has to do. It's not that difficult. Like, once you do it, then it's okay.
Yeah, that's fine.
I remember every single step that time with my yeah,
Just move. That's where the 10 gigs. So that gives me the number.
the university because I booked it out. Yeah. So that's my
video.
We also print it.
yeah,
I can bring the transformer around, and we can transfer it somehow.
okay, yeah. Do you have SolidWorks in your laptop? Then I have to do it.
Oh, image codecs. That's it. Image codecs 3.
Then I have to use SolidWorks.
Still need to solve some read on top, so that's fine.
So you need that in as well.
Yeah.
Now we build that. Build.
Why are you doing this?
I need to know contact.
Okay. Okay.
What?
The only problem is the battery.
It's that image code.
One goes into
The lid bit is put on the front automatically.
Yeah.
That's strange. I thought image codecs was.
I wanted to do is able to take it out. Charge or something. We'll have to figure something out. Maybe running off the manual.
What do you want to run? Because I have a Raspberry.
It's like
Sorry, this is. Shouldn't be
inside it. There's a bunch of capacitors in parallel.
Yeah.
So when the power goes into the pulse, it comes out and pulsating by power. But no power.
Yeah, but what do you... Right.
I'll show you. Right?
You usually have to program, right?
Oh, I don't know.
Really?
Yeah.
Not because I don't know how much really structure onto my...
Well, merge all together. I've moved one before, and then somebody told me, oh, they sell that for like £2.
At the moment, when I've got a copy of it, it's quite cost a bit much
Building this big,
I can't use it.
big things.
And my
But they apparently
memory card will come on.
so I've got one module.
And that's
Just messes with
it's
it.
wrong as well.
Yeah, you don't really have to worry about that.
Don't let
Because
you use 23 gigs of that.
I have to finish the calibration of my physical lab. Like, I kind of finished it. Nah.
No, like you'll see some bits.
You don't need to calculate. We can just make one design.
You'll see.
For example, I have a touchscreen.
So much for me being able to be
Yeah,
able
with this touchscreen, and then in this actually, I made place for the driver as well. So, and everything, like it was literally all around. No. Of course, around.
Yeah, it's good, but the components inside. It's like this cylinder with one flat end. And it's 2 wires out and 2 wires in. And it's 2 wires in. I want to put like 30 and the multipliers in
Waiting on the girl.
that should either
Just waiting on your message.
I don't really want to touch that.
it'll be fine.
102 amps, it's not.
Right, so I was looking
can make like
at the
2 different
diary
designs.
for
One for
IM
just say
and so now this
Hello, Mitchell.
will pick something up